Do you know what the number one gas in the atmosphere is? No. It's nitrogen. Yep, nitrogen. No, it's not. Nitrogen is not flammable. A lot of people think it's flammable, but it's not. Okay, that would be really bad, because as soon as somebody lit up to take a smoke, what would happen? Especially when there's 78% of it in our atmosphere. Okay, every breath you take, you're breathing in 78% nitrogen. Okay, this nitrogen is not dangerous. Okay, in fact, it's inert. This nitrogen here that's in our atmosphere doesn't do anything. It doesn't react with anything. It doesn't do anything. It's just taking up space. In fact, plants need nitrogen, and they can't even use this nitrogen because it's inert. Okay, they can't use it. So it actually has to be fixed in order for it to be usable. There's two ways that it can be fixed to be usable. One is with lightning. So when lightning actually strikes, and we see that lightning actually can fix that nitrogen into a usable form. And the plants, there are a certain plant called alfalfa, and there's other plants, have actually little nodules on the roots that can actually fix nitrogen into a usable form. So nitrogen, plants that love nitrogen, planting alfalfa next to them would actually really benefit them a lot, because it would give them all the nitrogen that they needed in a good usable form. But we can't do anything with it because it just sits there, and the majority of our atmosphere is made up of this stuff. What do you think number 2 is? It's oxygen. How much? 21%, yeah. 21%. Good. Good guess. 21% is oxygen. Yeah, there you go. So we've got 99%. Interesting thing about oxygen is that our planet, at the very beginning of the life of our planet, didn't have oxygen. It had CO2. And when we look at all of this oxygen, where did it come from? It came from plants. So if we actually charted this thing out and looked at it over time, and I'm going to put time right here, and I'm going to put amount right here. So obviously as we go up, it increases, right? So if we look at the formation of the planet a long time ago, our CO2 levels were actually way up here. Guess where our oxygen levels were? 0. They were right down here at 0, and CO2 was up here. That's true. So was there oxygen here? Yes, but it wasn't free-forming oxygen. It was always attached to something. Okay, so like the CO2. We had lots of CO2. That CO2, if you look at it, it does this, and all of a sudden it drops dramatically, and then it flattens out down to that really small percentage. Why do you think that happened? Plants show up. So we know that when we start seeing a drop in CO2, we can actually look at the record of the Earth, and we can see that plants, we start seeing plants. That plant, or the blue-green algae, or all the other photosynthesizing plants, start taking that CO2 out of the atmosphere and turning it into oxygen. Weird thing is oxygen, guess what we see it do? It has the opposite effect. So as the plants are taking up the CO2, they're spitting out oxygen. So we see a decrease in oxygen, but an increase in O2. We know this for sure. One is that we can see plants, we can see fossilized plants. Another thing we see in this, well, we know that when plants or life actually began, because we see a little thing called iron-banded formations. When we look at the layers of the Earth and we go far back in time, there's actually a point, if we have layers of the Earth, say if we were going down to the Grand Canyon and we had all these layers, the youngest is at the top and the oldest is at the bottom, we get somewhere around in here And guess what we see from that point on? Well, we have iron here, but what happens to iron when it comes in contact with oxygen? It rusts, it oxidizes. So we actually start to see rust here. Before that point, guess what we don't see? No rust. So if there's no rust found in the earth at that point, then there can't be any what? No oxygen or plants. It's really solid evidence that we know when oxygen and life started to form because we can actually see it written in the earth. We see the rust where it starts to form. Which is interesting because now when we talk about Mars, Mars is the red planet. Why is it red?
It rusts.
Because it's made up of iron and it rusts. In order for it to rust, it has to oxidize. In order for it to oxidize, it has to have what? Oxygen. Okay, which probably is pretty good evidence that Mars was probably covered in water, may have had some vegetation and oxygen on it as well in order for it to be rusty like it is now. 99%, right, is made up of nitrogen and oxygen. So now, what about that 1%? Well, so let's look at the third layer here. The next most abundant gas is argon. Argon. Okay, argon is also inert. It doesn't do anything. Argon is right over here. It's number 18. Anything in this column here is inert. Argon's inert, so it doesn't do anything either. How much argon do we have out of that 1%? 0.93%, which means out of that 1%, 93% of that 1% is argon. And it doesn't do anything for us either. We have 0.07% left. In that 0.07% left, we have methane, CO2, helium, hydrogen. We have all these other gases that are out there. There's a lot. Okay, we have all of those gases that are up there, and that makes 0.07%. So let's take a look at one of those gases that we're most concerned about. Number 4 is CO2. CO2, the amount of CO2 we know that we have in our atmosphere is 0.0387%. Yes, it is rising. That's a really, really small percent of CO2. But why are we concerned about CO2?
It's a suffocating gas.
Well, a lot of these gases will suffocate you. Nitrogen will suffocate you too. It warms the earth. Okay, so CO2 acts like a blanket. So when you have CO2 on our planet, any of the heat that tries to escape, CO2 traps that and sends it back down. And it keeps us nice and warm. It's a super small percent. So this is the one that keeps us definitely warm. We want it. We definitely want it. But if I move that up to 0.04%, what would that do to our planet?
Too hot.
Okay, it will definitely make things warm. If I dropped it down to 0.02%, it would get really cold. Does it take a lot for us to actually manipulate those numbers? No, it doesn't. So hopefully you can see why we're concerned about CO2, because it's what keeps us warm, but we're only talking about a very, very, very small percentage that actually keeps us warm. So if we add a little bit more to this, we're going to warm up. If we take some away, we're going to cool down. And currently right now, we're taking things out of the earth and warming the planet up because we're actually taking CO2 out of the earth, putting it into the atmosphere where it doesn't belong. So CO2 is an important gas. Now I'm going to go through all the other gases. We have methane and other ones, and they're very, very small, and we don't focus on them a lot. The 4 things that we really want to look at: nitrogen, oxygen, which makes up 99% of our atmosphere. Then the argon almost makes up that 1%, but not quite. And then the other gas we're really concerned about is CO2, because that's something that we are actually producing. That is something that we can actually try to slow things down. What do you think the next gas in our atmosphere is that is of high abundance?
Two.
It's me.
Oh. Water.
Water. Water vapor. H2O. Water vapor. Okay, so water vapor is definitely something that we are concerned about because water vapor is a very strong greenhouse gas. Most of you know this. You ever been into a bathroom when after somebody's had a really hot shower and the whole room is full of water vapor? Is it hot or cold?
It's hot.
It's hot, yeah. Water is really good at hanging on to heat. And if you've ever been down to an area that has a lot of humidity, like down in the south, then that humidity has the ability to trap a lot of heat. And what happens? Well, it gets really hot, right? If you have high humidity, it gets really hot, and that's because of water vapor. Water vapor is really super good at collecting heat. But we don't count water vapor as part of the composition of the atmosphere. Part of the gases, even though it's there, we don't count it. Any idea why? It's true, and that's a part of it. So if it's in the atmosphere, it's going to be a gas. But if it cools down, it will turn into what? It will turn into a liquid. Okay? Because of that, water vapor only exists. It's only in the atmosphere for about 10 days. Okay? Well, so if we evaporate water into the air, within those 10 days, it's going to come back out again. So it may come out of snow, it may be a cloud, it could, whatever the case is, it's going to fall back out of the atmosphere. So it doesn't stay there. These gases, they're staying. This one is only there for about 10 days, and so they're not going to stick around for very long. So we don't really count it as part of this composition because it just comes and goes. It's never actually there long enough to actually make a big impact on things. But does it make a big impact? Yeah, I mean, okay, all the snow, all the rain, all that stuff, all the weathering that takes place on our planet is due to that water. But it's because it falls out of our atmosphere. If it stayed up there all the time, then our planet would be really hot and we probably wouldn't have any of the rain or the other things that we have here. What do you think another little vital part of our atmosphere is? You ever caught snowflakes on your tongue?
Yes.
You ever caught raindrops in your mouth?
Yes.
Barely? Oh, well,
When it hit you in the eye.
okay, hit you in the eye. Okay, so I'm going to tell you a little bit about those raindrops and those snowflakes, and you may not be too happy with it.
Let me guess. You have a whole bunch of dust.
Well, okay, so we have a little thing called aerosols.
What?
Aerosols. And an aerosol is a tiny, solid, or liquid particle in the atmosphere.
Let me guess. It connects to.
Well, okay, so if it's a tiny, solid, or liquid particle in our atmosphere, what do you think those tiny, solid particles, liquid, are? Give me some examples. What do you think? What do you think, Scott? Okay, ice crystals. Yeah, some of those are for sure, but we want to look at a few other things. Yep. Yeah, absolutely. So insects. Yeah, I've seen hailstones that actually have fallen to the ground, and I've seen bits of wing. You can have antenna. You can have other things in there. Absolutely, you can have bits and pieces of bug in the sky for sure. Yeah, especially if you've been eating those snowflakes. Okay, but guess what the number one thing is? Salt. Yep. Salt loves water. Salt loves water. It's hygroscopic, so it's water seeking. And where do we get all the salt? Well, think of all the coastlines that we have, and every time a wave crashes along the coastline, it's going to shoot up a mist, and that mist has salt in it. So a lot of times when you go to the beach, the air may taste kind of salty, but that salt, once it becomes airborne, it can travel around the planet, and there's a lot of salt in our atmosphere, and salt loves water, and so guess what happens to all those little tiny bits and pieces of salt? It collects water on there, and then once it actually gets enough water, it can fall out of the atmosphere.
Like sometimes snow melt instantly.
No, it's just touching something warmer. Dust. Dust is another thing. Get a good wind. Comes in, blows up a bunch of dust into the air, and we can get a lot of dust into the air. Just to let you know, every raindrop, every snowflake cannot fall to the ground unless it has a particle inside. It has to condense on that particle. So every raindrop, every snowflake that you see actually has an aerosol in it. So why after it rains and you look at your car, how's your car look? Dirty, right? That's because it leaves all of that stuff, all of that rain has it. About 6 years ago in the springtime, we had a major storm that came through, and we had major wind that came through and blew up a whole bunch of dust. And it got way up into the sky, and then it started to rain, and it literally rained up in Lehigh and Pleasant Grove, mud. Mud was falling out of the sky because there was so much dust and the water. Yeah, we had mud falling out of the sky. Yeah, it was a mess. You had mud everywhere. It was disgusting. Okay, so dust is there. Another one is smoke. Smoke is not a gas. It is an actual particle. That's why when you get smoke in your eyes, it hurts. Because when you get smoke in your face, you close your eyes, and you have all these little tiny pieces of particles in there that start scratching your eye, and it gets really painful. So you open your eye, and your eyes are all watery, and there it all cleans it all out. Another one, pollution. Pollution is a big one as well. So we get a lot of pollution that can go up into the air. We can get some nasty stuff that we can get, especially if it's like sulfur. We get sulfur in the air and water attaches it, then we end up getting what's called acid rain. So the water will turn into an acid. But have you ever noticed after it rains, the air seems to be a little cleaner? Okay, it feels a little bit better, and that's why. Because the air is literally cleaner. It's cleaned all that stuff out. It's everywhere. It's a mess, but it's there. What do you think another thing is that is in our atmosphere that we actually need to pay attention to? Start with an O. Z. Good. Ozone. Ozone, ozone, ozone. We want to talk about ozone a little bit. Where is the ozone layer? Above the sky. How about it's found in the sky? Do you remember where it's at? Next one up. Stratosphere. Good. It is in the stratosphere. What is ozone? Well, no. You don't want to be around it. Ozone, all it is, it's 3 oxygens, O3. That's all it is. It could make you a little sick. Have you ever used a drill or maybe a blow dryer or something, and it's been underneath some strain, and the motor actually starts to make a weird smell? You ever smelled that before? That's ozone. Electric motors produce ozone. Computers produce ozone. So when you smell that, did it make you feel, oh, yay, it feels good, or does it kind of make you nauseous and sick? Yeah, ozone for humans is not a good thing. It makes you really nauseous. It will make you really sick. So if you're around it, it doesn't make you feel very good. Oh. Do we need it?
No. Yes. No. No. I can't even.
Which one? Yes or no? We do need it. Why do we need ozone? It protects us. So I'm going to... go back here for a minute. If you remember, it's in the stratosphere. And we have two different types of ozone. We have tropospheric ozone, and we have stratospheric ozone. So down here at the troposphere, we have ozone that's found here, and then we have the stratosphere that's found up here. And the ozone layer is roughly about right here. And we are, yay, down here. Okay? Stratosphere. We want it right in here. Why do we want that? Because when we have radiation comes down, especially that UV, some of you were saying the numbers before, how much of that does it block out? 95%, which means how much goes through? About 5%. So that's your sunburn. That's what you get, is that 5%. If we didn't have ozone, what would happen? We'd be crispy critters, right? We'd be like bacon, really crispy bacon. And we'd walk around this, and if you're getting burnt by 5%, can you imagine if we jumped it up to 10% or 20%? That 5% will burn you in 12 minutes. So if we bump it up to 10%, now it's 6 minutes. We bump it up even more, what happens? You're just outside going to go get a drink at the store, and back you come back, and you'll be like, you will have boils, you'll have all kinds of stuff all over you. Yeah, if we didn't have that, I mean, we're only talking about 15%, right? 95%, can you imagine what that would be like to have all of that come down?
And then 20% is 90%.
So, yeah, take a look at this. Plants. Would we have plants here if we didn't have ozone? No, they'd be gone. We'd be gone. There'd be no oxygen. Life would cease to exist without the ozone. So do we want it? Yes.
It's a shield.
We want ozone. We want it to block it away from us, but we don't want it down here. No. Ozone. Why? It will make you super sick. If you've been in a computer lab room for a long time, you might actually feel kind of nauseous and sick while you're in there because those computers are producing ozone. They produce a lot of ozone, and it can make you actually really sick. It's something that you don't really want to be around. Lightning produces ozone. Have you ever plugged something into the plug and pulled it out and had a spark, and there was a smell? That's ozone.
I hate that.
Okay? It's ozone. You had the energy that was there to be able to take 3 oxygen and combine them together and make ozone. So we don't want ozone near us because it's a pollution to us, but we do want it far away because it protects us.
It's a shield.
It is a shield, as long as it's far away from us. We don't want to be near it.